Now let us start with the second problem. Here we have the question. A multiple plate clutch has steel on bronze is to transmit 8 kilowatt at 1440 rpm. The inner diameter of the contact is 80 mm and outer diameter of the contact is 140 mm. The clutch operates in all There is a correction. The clutch operates in oil. Expected coefficient of friction is 0.1. So it is in oil. Expected coefficient of friction is 0.1. Allowable pressure is 0.35 megapascal. Assume uniform wear theory and determine the following. The first one, number of steel and bronze plates. Second one, axial force required. Third one, actual maximum pressure, and fourth one is the average pressure. So these are the parameters to be determined. We have to determine, and let us see what are the given parameters in the question. So we have power 8 kilowatt, speed 1440 rpm, inner diameter 80 mm, outer diameter 140 mm, coefficient of friction 0.1, and allowable pressure. Allowable pressure is 0.35 megapascal, and it is given in the question. We have to assume uniform wear theory. So first finding, let us find the number of steel and bronze plates using uniform wear theory. And here we have equation number 13.9d for uniform wear theory. Axial force F is equal to 1 by 2 pi into P max into d1. It is di also, d2 minus d1, that is d0 minus di. So this is the equation what we have. So substituting the parameters, maximum pressure as 0.35, d1 as 80 and d2 as 140. We calculated axial force as 2638.94 Newton. In the uniform wear theory, we have the equation number 13.9e. It is not C, it is E. Equation number 13.9e. Torque transmitted by one pair of friction surfaces T is equal to 1 by 2 mu into Fa into dm. This is what we have, and we multiply the number of friction surfaces. So this is the equation what we have. So here we have one unknown, and that is torque T, and one more unknown is the mean diameter dm, and number of active surfaces I. So these are the unknowns. So to find torque, we know the equation torque is equal to 9.5 into 10⁶ power divided by speed. So substituting these parameters, power as 8 kilowatt and speed as 1440 rpm, we get torque as 530.55 into 10⁵ Newton millimeter. And to calculate the mean diameter, from equation number 13.9f, below that equation, we have dm is equal to d1 plus d2 or di plus d0 divided by 2. We get mean diameter as 110 mm. So substituting these parameters in the equation number 13.9e, it is 13.9e. P value as 530.55 into 10 raised to 2, 1 by 2 as it is. Coefficient of friction as 0.1. Axial force we have calculated 2638.94 into mean diameter 110 and active surface I as it is. So here now we have only one unknown, that is number of active surfaces I. So which is calculated as 3.66. So approximately we can write it as 4 active surfaces. Next, number of discs on the driver shaft, that is bronze plates. On the driver shaft it is a bronze plate. So this you need to remember. On the number of discs on the driver shaft is given by I1. I1 is equal to I divided by 2. So 4 divided by 2, because I value we have 4. So it is number of discs on the driver shaft I1 is equal to 2. Next we have number of driven shaft. Number of driven shaft, that is steel plates. Okay, for steel plates we have I2 is equal to I1 plus 1. So I1 value we have 2 plus 1. So number of discs on the driven plate on the driven shaft is 3. So I1 value 2, that is on driver shaft. I2 value is 3, that is on driven shaft. Therefore, total number of discs we have I1 plus I2. You need not to use this symbol I. Okay. Total number of discs we can write I1 plus I2 is equal to 5. 3 plus 2 is equal to 5. I repeat, you should not write this symbol I. Okay. You just write total number of discs is equal to I1 plus I2 is equal to 3 plus 2 is equal to 5. So this is the first bit in the question. So second bit in the question is finding the axial force required. So for uniform wear theory, we have equation number 13.9e. So this is 13.9e again. We have this equation mt is equal to 1 by 2 mu into f into dm into number of active surfaces what we multiply. Writing this for FA, that is axial force, we can write it as 2mt divided by mu I into dm. So substituting the parameters, mt as torque transmitted as 53055.56, mu value 0.1, I value is 4, that is number of active surfaces, not total number of discs. Okay, so I mention it once again, don't use this symbol I. So number of active surfaces is 4 and mean diameter is 110. So axial force is equal to 2411.6163 Newton. So this is the axial force required. Next we have actual maximum pressure. To find actual maximum pressure, let us refer equation number 13.9d. Equation number 13.9d. So in that equation, writing it is for axial force, we will write for the maximum pressure. Pmax is equal to 2Fa divided by pi into d1 into d2 minus d1. Okay, you please write this equation for maximum pressure. If you modify this equation, you will get this equation. So here substituting the values for axial force as 2411.6163, pi d1 value we have 80, d2 value we have 140. We get maximum pressure, actual maximum pressure as 0.32 Newton per mm square. Next, the fourth bit in the question, finding the average pressure. For this, we don't have exact equation in the data handbook, but with a little modification, okay, we can obtain this equation by modifying equation number 13.9d itself. So here you have to write it as a mean pressure. Okay, mean pressure, not maximum pressure, it is mean pressure. Mean pressure is equal to 2 into fa pi. Instead of d1 you have to write d mean, because we are finding mean pressure. So when you want to find mean pressure, instead of smaller diameter you have to use mean diameter. So average mean pressure is equal to 2 into fa as 2638.94 into divided by pi into 110 as the mean diameter into 140 minus 80, and you will get average pressure or the mean pressure as 0.2545 Newton per mm square. Now to find the actual pressure, that is to find actual average pressure, we have this equation Fa is equal to 1 by 2 pi into P into dm into d2 minus d1. Again I have modified the same equation, I have written it for the axial force. So here to find actual average pressure, you have to substitute axial force as actual that is actual axial force required as 2411.62. It is not the axial force what we have identified initially. It is from bit number 2, axial force required Fa as 2411.62, and substituting remaining parameters we can find actual average pressure as P mean as 0.2326 Newton per mm square. So this is the solution for the second problem.